All right, now, ladies and gentlemen, we're going to take it one step farther, and this time we're going to focus on the second half of that same lesson 8.6, and we're going to solve factored quadratics. To do that, again, we're working on these skills, but now we're going to apply that zero product property that we talked about a little bit back in, I don't remember which lesson, but that zero product property tells me that if A times B equals 0, then either A equals 0 or B must equal 0. And this is a really essential idea of math. 0 is the only number that does this, that if we multiply any number by 0, we wind up with 0 as the product. So the reason we care about this is now, if we're looking at a quadratic in factored form, we can use that zero product property. If I know that x plus 14 multiplied by x minus 3 equals 0, I know that either x plus 14 equals 0 or x minus 3 equals 0. That zero product property tells me that either this piece times anything equals 0 or this piece times anything equals 0. So now I'm going to use those equation solving skills from way back at the beginning of the year, where I can take away 14 from each side, and I know that on this half, if I want that expression to equal 0, x must equal negative 14. If I want this half to equal 0, I have to add 3 to both sides, so x is 3. So my final answer is x equals negative 14 or 3. Now, if x does equal negative 14 and I plug this in here, I get negative 14 plus 14 times negative 14 minus 3. Does that really equal 0? Well, let's check. So negative 14 plus 14 equals 0 times negative 17. Well, that works. Even though this half, the second half, didn't equal 0, it doesn't matter, because as long as one piece equals 0, my total product will be 0. And the same thing, if I plugged in negative 3, I would get 11 times 0, but it still equals 0. So both of these are possible solutions now. If I practice this again, well, I'm using that same idea that either A equals 0 or B equals 0. So I can rewrite this. I know that either 4x plus 8 equals 0 or 3x minus 9 equals 0. Solving this first half, if I take away 8 from both sides, I get 4x equals negative 8. Divide both sides by 4, and I get a final answer. One possible value for x is negative 2. If I try the other side, I can add 9 to both sides, and I get 3x equals 9. To get x by itself, I need to divide both sides by 3. And I get a second possible answer for x is 3. So my final solution is x is negative 2 or 3. Now this one here was a little more complicated. On that first example, I could just take the opposite of whatever it was. But when I have that coefficient in front of x, I need to follow my steps here. So I think it's good to get in the habit of following the steps, even if you think you can answer it before. So let's move on now. Now we're putting all the pieces together. In our last lesson, we talked about how to factor this, and now we can use that zero product property with our factored quadratics in order to find the zeros. So if I think about my steps from the last lesson, I need to find any greatest common factors, and then I'm going to use the idea of factors that multiply to make the last term and add up to make the middle term. I see a coefficient on my x squared though, so the first thing I need to do is I need to get rid of it. I'm going to take out that negative 1 from each of the pieces of my trinomial, which turns this into x squared plus 15x minus 54 equals 0. So I need factors that multiply to make a negative 54 and add up to make a 15. Something happened with my video here. So what I had done before is I had that negative 1 pulled out of each piece, which changes the sign on each of my terms. So now I know that I need to find those factors that multiply to make negative 54 and add up to make 15. And so I can run through the whole list of factors, but at this point, if you're ready to move on, we know that we're going to have -1. Can't forget that coefficient out in front. I know that one of my factors is going to be positive and one is going to be negative to give me that -54. I know that the greater factor must be positive because my addition answer is positive. So the pair of factors that works is 18 and -3. When I plug that in here, now I see that I have -1 times x plus 18 times x minus 3. Using my zero product property, I know that one of my three factors must equal 0. Well, -1 can't equal 0. There's no variable there. So I can solve each piece to determine the possible solutions. So I get either x plus 18 equals 0 or x minus 3 equals 0. So that tells me that one possible solution for x is -18, and the other possible solution is +3. So my final answer is that x is 3 or -18. I've put all the pieces together now. I can factor it out, and I can use those factors to find my zeros, and I have solutions. Let's try it again. This time we have x squared minus 16 equals 0. And if we look at this here, it might appear that that middle term is missing. If you think back to our lesson on binomial square patterns, you might recognize where we're going with this. But if I want to rewrite it in standard form, this would be the same idea as having x squared plus 0x minus 16. I know from my zero product property that 0x is the same as 0. So now if I'm thinking about finding those factors, I want factors that multiply to make a -16 and add up to create 0. So if I do that, I know that my x's, one's going to be positive and one's going to be negative because I wind up with that negative multiplication piece. And this one here, this is that idea of adding, or what do we call it? The difference of, not difference of squares. Difference of squares. I think it is called difference of squares. Your textbook has some different names for these processes. But what we do is we find out that x plus 4 times x minus 4 is that x squared minus 16. So now my zeros, I know that either x plus 4 or x minus 4 equals 0. So my slide keeps having trouble here. I know that my possible values for x are going to be -4 and +4. And I can take that from my factored form where I had x plus 4 times x minus 4 equals 0. Last one here that we'll do is a homework problem. This one's number 27 in the homework. When I see this, I have d squared plus 56 minus 18d. So this here is not yet in standard form. My first job is to create it in standard form, and I want to set that expression equal to 0. So to do that, I need to add 18d to both sides, which turns my expression into d squared plus 18d plus 56 equals 0. When I add 18d to -18d, it goes away, and I'm left with just 0 on that side. So now if I think about my factoring, well, I see that I have that multiplication piece is positive, so I know that either both of my factors are positive or both are negative. Well, if I look at my addition piece, it's positive, so I know that my two factors are going to be positive. So I need to go through the process to find two factors of 56 that equal 18 when I add them together. So my two factors are going to be 4 and 14. And again, we can run through the process. We can find each of the factor pairs and then add them together to figure it out. But I know that they're both positive and need to add to 18. Last step, oh, I turned these into x's. These are d's. It's our placeholder, but we want our placeholder to match the way that it looks in our original expression. So that means that my zeros, my two solutions for zeros, are going to be -4 and -14. Alrighty, that's it today for 8.6. So now your homework task is 6 through 30, multiples of 3, and then numbers 37 through 39. Not a super long one here, but I want you to take your time. Be careful with those positives and negatives. Now we're taking that next step. We have factored, or we're working on factoring, and then finding the zeros. Make sure that you're checking in on Delta Math and working on these skills as well. Thanks, ladies and gentlemen.